Welcome to Aberdeen Drilling Consultants Virtual Academy. The Virtual Academy is an online training environment for the oil and gas industry, which covers rig inspection, drilling equipment, dropped objects, and Level 2 well control training. Welcome to Webisode 5. In this webisode, we will talk about the circulating system. Drilling fluid, also known as drilling mud, is very important for drilling wells and serves a multitude of purposes. Drilling fluid is used to keep the drill bit clean, lubricated and cool while drilling. It cleans the wellbore, transports the drilled cuttings back to surface, prevents the cuttings from falling back to the bottom of the well, seals the permeable wall of the wellbore when it solidifies to produce a filter cake, helps to support the drill string. Data loggers use the properties of the mud to monitor the drilling process using specialized tools. The most important use of drilling mud is maintaining the primary well control. The hydrostatic pressure exerted by the column of fluid in the wellbore prevents gas or fluids from entering the well, where it could pose a hazard both inside the well and at the surface. This is achieved by carefully measuring and adjusting the density of the fluid. Drilling fluid comes in a variety of types, such as synthetic-based, oil-based, and water-based. Each type of drilling fluid has different properties and with it advantages and disadvantages over other types of fluid. While drilling, fluid is pumped down the well inside the tubulars and exits through the drill bit where it collects the drilling cuttings. The fluid is then returned to the surface up the annulus, transporting the cuttings up the wellbore. The cuttings are removed as the fluid and cuttings flow over the shale shakers. The fluid is then returned to the mud pits where it can be then reused. Here is the full cycle in more detail. Drilling fluid starts out at the mud pits. The mud pits are a series of tanks where the drilling fluid is stored. During drilling operations, one or more pits are assigned as the active mud pit. The active pit is monitored to ensure the correct amount of fluid is returning. Chemical checks are done on the returned fluid, as well as the physical checks to ensure that the density and viscosity are correct. Using the active pit gives a closed system which makes it easier to monitor. Dry powdered gel or other additives can be added to the mud. There are a number of additives available which change the properties of the mud. For example, barite is added to increase the density of the fluid to keep the hydrostatic pressure correct in the well, while bentonite is used to increase the viscosity of the fluid. The fluid is pumped from the active pit to the mud pumps at a low pressure using charge pumps. The pinion drive shaft of the mud pump drives the main bull gear which turns the crankshaft. As the crankshaft rotates, it generates the linear movement of the crossheads which moves the pistons in and out of the liners. The suction and discharge valves at the fluid end open and close, allowing the fluid to be pumped down the well at high pressure. Rigs use multiple mud pumps to achieve the right pressure and flow. The fluid being pumped by the mud pumps goes up through the standpipe manifold and down the drill string. Once it reaches the bottom of the drill string, it comes out through the jets on the drill bit and moves up the annulus, the area around the drill string. As it moves up, it holds the drilling cuttings in suspension and carries them up the annulus. When the fluid reaches the surface, it flows down the flow line and onto the shale shakers. The shale shakers have vibrating screens. The fluid flows through the screens and the drill cuttings are collected. If the mud is water-based, the cuttings may be discharged overboard. However, if the mud is oil-based, the cuttings are stored in containers to be transported ashore to be processed. It may be necessary for small bubbles of gas to be removed from the fluid. This is done using a vacuum degasser. The action of the fluid flowing over the baffle plates of the degasser separates the gas from the fluid. The vacuum pump then draws the gas out of the unit to be discharged, either at the top of the drilling mast or at a safe distance from the rig. During well control operations, a pour-buoy degasser is used as it can handle much larger amounts of gas. The drilling fluid is monitored by the crew and kept in good condition. If there is too much solids in the mud, it can be removed by using the desander for coarse solids, desilter for smaller solids, and a centrifuge for removing the finer solids. Once the fluid has been treated, it is returned to the active mud pit and the cycle starts over. If you would like to find out more about the content covered within these webisodes, or about the Virtual Academy, then please contact Aberdeen Drilling Consultants.